multiples. That's evil.
Yeah. Basically, yesterday you had to keep in mind what day it was. Yep.
Did you do anything good?
Anything that shows up that's like shocking, you have to kind of question it.
Did you do anything good?
Yes, several times I did nothing at all. That was awesome. But most of the time I was doing too much for a break, right? You know, I'm in Panera grading papers, and these people come by and they say, "This is a teacher's spring break for here." Rodney. Yeah. All right, guys. I want to finish out chapter 4 today, but I want to start with. Well, first off, any questions from homework? Then I got some stuff, a review to do from that last section we did, section 4:7. So I have some stuff to do out of the blue book here. Any questions from homework? Yes, Paul. Number 93. Oh, cool. So this thing gives you a table. It says a fraction of the Earth's water area per ocean. So this is the Arctic is 1/25th. The Atlantic 13/50th. Pacific is 1/2. So half the world's area of water is in the Pacific Ocean. The Pacific accounts for half the world's area of ocean. So it says, this question says, what fraction is accounted for by the Pacific and the Atlantic Ocean? So what operation do I have to end up doing on those? Adding. Cool. Now, guys, I want to focus on this a little bit because I've already seen a couple of homeworks turned in, and I want to show you the mistake. I'm not making fun of anybody. I just want to show you the mistake because it actually happens often. I just forget that it happens. So when you want to go add these together, of course, what do you need before you can do that?
Common denominator.
And what's the LCD going to be? 50. It's not 100. It's too big. I don't need it to be 100 because 2 itself can become 50. 50 doesn't have to change at all. So it's not always just the multiplication of the two denominators, right? The only time it's that is if they don't have anything in common. Okay, like 7 and 8, that would have to be 56. Here they have something, they have a 2 in common, so actually it only has to be up to 50. The mistake I see is this. You identify the LCD as 50, no problem with that. But then this suddenly becomes 1/50th and 13/50ths. What happened?
You forgot to multiply the top.
So if you do that, you're claiming that 1/2 is the same as 1/50th. And the minute you claim that, then all of math doesn't mean a damn. Right? Unfortunately, that doesn't actually work. You can't just... There, no math class needed anymore because I said that. No, you can't. But so you have to...
25.
This is really, when you do this, it's a process of unreducing, if you want to say that. I'm not an English teacher, so I can get away with a lot. Don't live by my example. But, I mean, reducing is taking common factors and canceling them from the top and the bottom. So unreducing is putting that factor back in on the top and the bottom. So overall, you end up with a number that's the same as it was before, it just looks different. Right? And don't forget, the whole point of adding fractions is it's like terms. Right now, this is 1/2 and 13/50. It's like 1/2 and 13 something else. Not like terms. Here, I'm stuck. Here, I can actually do something. I can force it to become like terms. I can't change the number, but I can change the way it looks. So, of course, here you should get...
Math is so violent.
What do you get here?
25.
So, of course, 25 divided by 50 is still 0.5. If you do it in your calculator, just like 1 divided by 2 is. It's the same number. It just looks different. And why the hell would I do it then? Because now, what's this?
48/50ths.
38.
38/50. Can't add.
50. Cool.
Well, would you reduce that?
And then you can reduce it, yeah. I always do. I always make my major point, and then I forget. And the last thing I always look at when after you finish adding or subtracting is, can I reduce it? What could go into both of these? 2. 19/25. Cool. Is there a follow-up on that? Oh, here? Exactly, it could. And if you take it back to 1/2, then you're back in the situation where you can't add these. You see what I'm saying? So it's sort of like this. I want to show you this example. I was thinking about this earlier when I saw this mistake, the mistake where somebody just made it 1/50th.
Said unreduced.
If you have 4/8 plus 5/8, why is that a really nice problem? It's already like denominators. But if I make the mistake and I go, oh, 4/8 is 1/2, now I've kind of screwed myself over. I've reduced that, yay, but then the actual problem I can't do. So if I start here, I'm thinking, oh damn, somebody reduced already. I got to unreduce it. That's my thought process. Somebody reduced the damn thing. Shit, I got to multiply back by that 4 they killed, so I get it back to like terms. Does that make sense? I mean, that's really when we see a fraction, they don't have the same denominator. Oh, somebody reduced something. People. And then so you got to build them back up so they're back to the point where you can add them together. Yes, sir.
If you make that one 4/8 plus 5/8, again, can you, before you start adding them, can you take the 4 and 1 4 into 2 8?
Oh, like this?
Reduce it?
Like this? What's the operation? What's the bar mean?
Division.
And what's in the middle there?
Addition.
Are they opposite operations? So can you cancel due to them? No. Does that make sense?
So it was multiplication is good.
Exactly. If it was multiplication right there, then you could cross reduce and up and down reduce all day. But, I mean, it really is that simple. All throughout all of mathematics. I don't care what level of math you're in. Math 88, Math 285, I don't care. You cannot cancel something if the operations involved are not opposites. That's a fundamental thing throughout all of everything. Don't start looking at it like, one day he said we could do that, and the next day he said he couldn't. These damn math teachers, they're all the same. No, I'm not. No, that's not. The operations have to be opposite in order for something to cancel that. Just make that make sense. And then that actually is less to memorize then. It doesn't memorize it here. It's just not opposite operations. Nothing new. Yeah.
Why would you like multiply 4 times 2 to be a, that's okay, but the first one, 4 times 1, why would you not multiply to 4 times 2 either? The same as
Oh, because there is not a 2 there. If it was, if it's 1/2 plus 5/8, there's a 1 there. I can't change that to a 2. So all I'm doing is, what must I do to this bottom to make it the same as that? So whatever the top is, it must also be multiplied by 4. That's the choice I have. I can multiply top and bottom by anything I want to except 0. Anything I want to. So of course here I'm going to be smart. I'm going to multiply top and bottom by the thing that makes the bottom the best thing it could be, which is the 8. Because then they're like terms. Does that make sense? So you don't have control over what's already there, but you have control over what you want to multiply by. Is that cool? So it's a lot like equations. Whatever you do to one side, you have to do to the other side, right? So whatever you do to the bottom side, you have to do the top side. The same way with fractions. They have sides too. All right? Yeah. Any other questions from homework? Yes?
Can you show us how to estimate, like for example, number 5 or 4.7?
4/7? Oh yeah, cool.
Because I was really stuck on those, the estimate.
All right, so when that says estimate, let me give you guys an example of estimation. So if I had 19 times 4.7, 4.187. If we had to do that, somebody tell me how I could estimate what that would be?
Okay.
I mean, 4.187 sucks. What number is that close to? 4. And then 19, I can make that even better. 20. And especially good because if I multiply two numbers, if I make one of the numbers bigger, the other number should probably get smaller so that overall it comes out close to what it should be. Does that make sense?
Yeah.
If I make this number smaller, this number should get a little bigger. So this should be about 80. Now how does that relate to what we're doing right now? Because in real life we see decimals actually more often than we see fractions, right? Is that true? Yeah, we definitely do, because we buy stuff. Right. And there's decimals involved. And you go to get gas, and they got a third decimal place, if you ever noticed that. It's always freaking 9. Yeah. So if I have 2 and 11/12 times 1 and 1/4, that's really close to what?
13.
That's
I mean, 3.
just below 3. You with me? 2 and 11/12 is almost 3. To be more precise, it's 1/12 away from 3. How important is that? Not really. I just know this is about 3. 1 and 1/4 is just what? Oh, I'm sorry.
So you don't convert like 2 times 12 and then add up?
Estimation means making the numbers you're given better. So estimation is never the exact answer. That's the idea. But in estimation, I want to estimate correctly. I wouldn't make this become 2 for 2 reasons. One, it's not close to 2.
It's almost kind of like a round.
And the other one, this one went up, so this one really should go
Yeah.
down. So 3 times 1, about 3, and then I see which one of those is closest to that, and they have 3 there. Is that, you guys see that? Yes, ma'am.
So it's almost kind of like rounding.
It is rounding, and it's rounding in a smart way. It's saying, what is this close to? But also, I made this one go up, so this one should go a little down. So overall, it comes out close to the same number. You guys with me?
Yeah.
So like 2 times 10 is 20. If I make that become 4, if I make that bigger, what does that have to become to make it still 20?
Smaller.
It has to be 5, it has to be smaller, so the overall comes out to be the same. So that's really what I'm doing here. Made that a little bigger, made that a little smaller. That should come out close to what it would have been anyway. Averages out. Does that make sense? Cool. That was number 5, thank you. So I have a question number 48 in that section 4.7. That looks gross. Let's see. 86 15s minus 27 and 3/10. And see, sometimes I say that kind of thing on purpose because I want you to realize I know math pretty well. But I still look at that and go, that's kind of gross. I mean, there's nothing wrong with that, except that, and then but don't make that be why you won't try it. Just go, okay, that's kind of gross. Let me be careful about this. But of course, I mean, what's the first step? I probably don't want to change these into improper fractions, because that's going to be humongous numbers. You could. Nothing really wrong with that. We should be able to handle it, but let's not. Because we need practice anyway with that possibly borrowing thing. Remember that? Oh boy. All right. So what do I really have to do first before I can do anything with these?
Find the same denominator.
Good. Find the LCD. Right? And 15
30.
is 5 times 3. And 10 is 5 times 2. All right, so you can do it that way, but this is not too hard to see. The other kind of classical way to do this is take the bigger one and start counting multiples of that. 15, 30, 45. Well, you got it, 30. Because 10 can certainly become 30. Is that cool? So there's not a damn thing wrong with doing it that way. This way would be, he's missing a 2, and he's missing a 3. Twice this and 3 times that are both 30. Hey, cool. Same answer both ways. So what do I have to multiply this by to make it 32? So I get 86 and 4 30ths. And here I get 27, and what do I multiply by? 3.
9.
9/30. And I'm trying to subtract them, so I see a problem right off the bat when I'm trying to subtract this. I love it. So I desperately want you to understand, this is exactly the same borrowing as we do before. I'm just borrowing not tens now, I'm borrowing ones. 1 is 1 over 1, is 2 over 2, is 70 over 70, is whatever over itself I want, right? So if I borrow, anybody see why I have to borrow? Because I got 4/30, 9/30, this is not big enough to handle that. Cool. So the tax man comes to the door, I go to the neighbor, I say, "You wanna borrow some?" Right, thankfully they don't do that.
Make that 85.
Not to me yet, anyway. So if I borrow 1 from him, so I add 1 to this guy. So what am I really adding?
30.
30 over 30. So the shortcut is you can pretty much always do 30 plus the top, the bottom plus the top. You get 34 over 30. Because 1 over 1 is always going to become this thing over this thing. So there's a little shortcut in there. But if you want to do it all the way out, this is 30 over 30. So what do I get now? This becomes 85, because I took 1 away, and 34/30. So you can see that extra 1 here. And this guy, of course, stayed the same. And now you can do that subtraction. 85 minus 27. So I got to do borrowing in there too. So what do you get there? Okay, cool. Are we good with that? No, what happened? What happened? Did I do the wrong? I never know anymore. It's too early in the morning. That's just normal borrowing, no big deal. And what do you get here? 34 minus 9. You guys got really quiet all of a sudden. Creeping me out.
25.
Maybe you'll forget where you... Yeah, 34 minus 9 is
Trying to let other
25.
people answer things. I'm not-
30th. What's up?
Nothing.
And then what can you do there? The last step. Yeah, the last step is always, can you reduce it? What goes into both of these? 5.
5, 6.
I like it.
So when you borrow and made that 86 and 85, and then you went plus 30 on, I don't understand that.
So when I borrow old school borrowing, like I just did, if I have 85 minus 27, do you really understand what it is you're truly doing when you put that little 1 up there? What is this? This is 80.
It's a tenth place.
So if I make it 70, I can put that extra 10 anywhere I need to. So I'm going to put that extra 10 there and make that 15. So really I'm doing the same thing. If I have 86, I can make this 85 plus 1. Well, that's incredible. And of course that would be 85 plus 30 over 30 if I really wanted to, right? Because that's 1. Is that cool? All right, and in the back of your brain, you're saying, why the hell would I do that? It's because what I really have here, now I want everybody to be cool with that. If I take 1 away from him, I can put it anywhere else I want to, just like taking 10, and I can put it wherever else I want to. So, if I have 86 and, what was it, 4/30, I can make that 85 plus 1 plus 4/30. Which is 85 plus 30 over 30, which is 85 and 34/30. That's really what's going on in the background there, right? Take 1 away from him and add it to this fraction. Well, I can't add it to the fraction unless they have like denominators. 1 always becomes that thing over that thing, right? 1's the easiest little LCD dude I ever wanted. So he becomes 30 over 30, makes it 34/30. Shortcut, if anybody wants to do a shortcut, 30 plus 4 is 34 over the bottom. Always works. All right, take 1 away from this guy, add these together, put it over the bottom, you're ready to go.
Can you do another one that you have to borrow like that?
Sure. Let's see. You can do it, Jeff. gross. All right. All right, so what's the first step here? I don't even know if I have to borrow yet. I just know what the first step is.
Gotta get
What's
to
the
that like denominator.
Yeah, I got to get like denominator so I can actually compare these things. So what's the LCD going to be? All right, so like I said, they both have a 7 in common, right? So this is 7 times 3, and this is 7 times 2. So what's he missing? A 2. Is that? Do you guys see that? Because I look at 14 and 21, and I'm the same way. I'm like, I don't know what the hell the freaking LCD is. Just looking at those two things. So I'd much rather kind of attack it a little more precise way. Let me break them down, and I can see who's missing what. So what do I want to multiply him by? What's he missing?
2.
A 2. And what's he missing?
3.
He's got a 2. He's missing that 3, right? So I get 92 and what's on the top? 4.
42nd.
42nd. Minus 45 and
39.
39. 42nd. How are we doing so far? Is that cool? I really would love it if you guys understood this step, this process. So like I said, you can do other things right now, but later it'll become really handy. When you get into stuff like you have to factor x squared minus 9, and then see who's missing what. It's a lot easier if you already know this process when you get there. Now, I'm at the step where I can see that I need to borrow. Because that guy can't handle that guy. So, the process, I take 1 away from him. And I add that 1 here, but I'm going to add 1 intelligently. I'm not going to make it 1 over 1. I'm going to make it 42 over 42. So, if I am allowed to do this, then I must be allowed to do that. It's the same idea. Take something from this guy. He's got plenty. He's freaking 90. Give me 10, dude. All right. And then I can put it on that guy. Now I can handle it. Here, same idea. This fraction's too small. Guys, this fraction's too small. I'm going to borrow. He's got plenty. I'm going to borrow 1 from him and attach it to this guy. Now he's going to be big. He can handle this other guy then. No problem. So this becomes
46.
91 and
46.
46 42nd. Minus 45 and
39.
yeah, that guy stays the same. And now you just do the whole number part you do like always. So you do like you just did over there. Borrow the 1. So that's going to be 40,
5.
46.
Oh wait, 11. No, I think it was 10.
46 minus 39. 7. And then your last step. You don't worry about this till the very end. Can I reduce that? Yes. 7 goes into 42. Good. So 46 and 1/6. Now, we'll throw this out there. I will throw this out there. Some of you guys have learned that your calculators have fraction buttons. So you're able to input fractions, and it will give you answers in fraction form, and you can convert it into mixed numbers and all that kind of stuff. I'm looking around at faces, and I'm trying to see if anybody's surprised with that. If you don't have a scientific calculator, you might as well get one. It costs like $12, and they do 300 functions or whatever. Right? So grab one of those. As I say that, that's an excellent way to check your work. It's no damn way to do your work. Right? So some of you guys, I know you have a fraction button because I can tell from the lack of work and the miracle of answers appearing. So be really careful. Right? If you're not sure about it, you can always come see me. I'll show you. I'll show you all day long because you still got to show me the work. But you can now check your work if you know how to use the fraction button in your calculator. Is that cool? Any other questions from homework? Yeah.
Section 43
4,
number 85.
3. Number which one?
85.
It's warming up. We better turn the AC on.
What's that word of mean?
Time.
I love it. So if you could just fill in this as a number, you just told me that means multiply. So all I'm missing is what that number is. And we know it means multiply. Half of 80 is 40. Because 1/2 times 80 is 40. The word of in English translates into times in math when you're talking about fractional parts of something or percentages of something. When we get to percentages, the same way. So all I got to do now is read through the problem and see, well, how many college freshmen are they talking about?
What number is that?
This is number 85, sorry. Page 243, number 85. So they say 4/25 of college freshmen major in business. So the only part that I'm missing then right now is, well, how many college freshmen are they looking at? And then I just need to multiply to see how many would major in business. So they say Pennsylvania Community College has 800 freshmen. How many of those freshmen would I expect to major in business? So it's 4/25 of the college freshmen. It's 4/25 times 800. And you can put that over 1 if you want to. You can always put a whole number over 1. And what am I allowed to do here?
Cross reduce.
I can cross reduce. Right? So I can say 25 goes into 800. How many 25s does it take to make 100? 4. 4 quarters make a buck, right? And then how many hundreds do I have? 8. So it's 4 times 8, 32. 25 goes into 800 32 times. How many rolls of quarters? If you had $8 you gave somebody, how many rolls of quarters should they give you?
Less than 1.
You know, how many total quarters should you get? Less than 1, Elaine.
Because there's $10.
I know. Right when I said rolls, I knew I was like, oh crap, it's the wrong way to say it. And then I just got to do 4 times 32. It'll tell you how many freshmen should major in business at that community college. Is that cool? Yeah.
One
Yeah.
more last question. Can you do 42, 4.7?
Oh. So is this the estimate part of it too?
Yeah, but just to get an idea of the exact and the estimate.
If I had to estimate this, if I had to estimate what this was, now, let me see if you guys are cool with this. Estimation's kind of freaky because when you multiply, if one goes up, the other one's got to go down. Well, what's 8 minus 2? What's 7 minus 1?
6.
So if I change one, I probably want to make the other one change the same direction so that they stay the same distance apart. Does that make sense? So if I make this about, what's 12 and 5/12? If I round it, it's closer to 12. Because it's not quite halfway to 13 yet. 6/12 would be exactly halfway. So this is about 12. This is about 4. So that should be about 8. It's not negative 8 there, but that's the approximation symbol. About 8. Is that cool? So part of this problem was estimate the answer. And it's always a good first step. So if I end up getting 50, I'm like, well, that's wrong. So I know I should get about 8. So let's attack this thing for real then. How do I do this and get the right exact answer? What do I have to do first? Like denominator, I love it. So I can, what's my LCD going to be? So who needs something?
The bottom.
Yeah, this dude needs a 2. So you get 12 and 5/12 minus 4 and 2/12. That's even better than the one we did earlier, right? Just
Don't have to.
Don't have to borrow. This guy's big enough to handle him. So I get 12 minus 4, 8, and 3, 12, which is 8 1/4. So our estimate of 8 is pretty damn good, right? It's not far from 8 1/4. That's fine. Is that cool?
So to check an estimation, actually do.
Yeah. Now, what in the real world, what's estimation used for? You're at a construction site. You got the guy on the phone. They're about to close. You want to order some wood so you can finish the freaking construction you're doing. You're going to estimate. You don't want to get too much wood. You're spending money that you don't need to spend. You don't want to get too little wood because then you got to freaking wait till the next day when they open and get more wood again and finish it. You want it to be done today. So estimation is in the field. There's no way to check it right there. You just estimate. So I wouldn't really do the work. I just go, I need about this much. Let me add some more on there so I'm covered, right? So I don't have to come back tomorrow. You guys kind of with me? I mean, that's estimation in the real world.
Can you do one more? Number 7 on that same section. Just dividing mixed numbers.
Oh, yeah. Now, when you're multiplying or dividing mixed numbers, you pretty much have to change it to improper fraction. Now, why is that? Because if I have this number 7 and 4 7, if I have 12 and 2 11ths divided by 3 and 9 tenths. One thing is, when I divide, what do I have to do? When I divide fractions, how do I do it? Multiply by the reciprocal. I can't reciprocate this. It's not just the top and the bottom. It's a whole number and the top and I can't. How do you turn that over? I don't want to just make it 1 over 3 and 9. That doesn't help me. So that's one reason why I pretty much have to convert to improper fraction. A more important reason is because what is 12 and 2 11ths? What does that really mean? 12 plus 2 11ths. And addition does not play well with division. So if I change it into an improper fraction, there's no addition anymore. It's kind of neat. So how do I, first step on this is change these into improper fractions and then just attack it like always. Flip the other dude. So see, what would this be? 11 times 12? What's 11 times 11? 121. And then one more 11 on top of that because I want 12 11ths. 132. Right? So this is 132 plus 2?
134.
134. 39. And now you can do normal stuff, right? So when you multiply or divide mixed numbers, you pretty much have to change it into improper fractions. So then you got 134 11ths times 10 over 39. And unfortunately for you, and for me, nothing reduces there. So you just have to, in a way it's kind of nice. Just multiply that thing, the top's not too bad, you just add a 0 in there. 10 times 39 would be 390. So 11 is one more 39. 10 39s is 390, so 11 39s must be 390 plus another 39. Let me say that again. 10 times 39 is 390. So 11 times 39 is one more 39. Add 39. So then you get 429. Cool. Let's go a little trick. Multiply by 11. Multiply, I actually, anything, really. Multiply by 13, you just do 10 times the thing and then 3 more of those things. Right? And if you needed to, you could change that back into improper, into a mixed number. Hopefully we don't need to. Oh, this is just the estimation. I'm being all crazy. That's why this is disgusting. If I want to estimate this thing, I was like extremely disgusted. If I want to estimate this, 12
And 4.
divided by 4, yeah, that's pretty good. Because that's really close to 12, that's really close to 4. So it should be about 3. And they got a 3 down there, awesome. Sweet. So if he said it was about 3 and they don't have a 3 in there, then obviously you take whatever's closest to 3, because that's what they're just trying to say. What's the best estimate from what we've given you? Is that cool? Yeah? All right. That's one of my sounds I don't like. That's one of my least favorite sounds. But if you say it's all good, then that's all right. Okay. So let me go ahead and give you guys, this is on page, I actually have the one from last semester. Hopefully it's about the same as the one you guys have now. Page 80. Can you look in your blue book? Is that the 4.7 practice on page 80? Oh, yeah. You guys see that? Page 80 in the blue book? Anybody need a copy of that? Oh. I don't know if I made it big enough. All right, so I'll tell you what, just so we're not, you need a copy? We're not spending all day on this. Do the even ones. Just do the even ones. Turn you off.